Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode MIDI 1039, which is minimum score triangulation of polygon. This question will be based on dynamic programming and it is recently asked in Google, Amazon and Uber in the coding interviews. The problem is marked as medium, but I will be making it easy for you all to understand. Let's not directly read the problem statement. I will explain it with the I will explain it to you with the help of an example. So what is given to us? We are given an integer array, and in this integer array, these are like weights of certain nodes. Maybe let's say in this integer array, we have 4 items. So we have 4 points in our polygon from right to, or maybe in the clockwise order. These are the weights 3, 7, 4, 5. So this is our polygon which is given to us, and what we have to do is we have to do the triangulation of this polygon, breaking down the polygon in form of triangles. A triangle require only 3 points, 1, 2, 3, and we can have n points. So using those n points, first of all we have to do the triangulation, and then we have to find the minimum possible score of that triangulation. And what is that score? Maybe let's say in this polygon, if I am doing something like this, I have divided this polygon into triangles. There are 2 triangles. So what is the score of each triangle? This triangle has a score of 3 into 7 into 5. 3 into 7 into 5. Plus this second triangle has a score of 5, 7, 4. 5 into 7 into 4. So this is the score. But there might be the chances that I am doing the triangulation in a different way. 3, 7, 4, 5. 3, 7, 4, 5, 1, 2. This is the polygon. And if I'm just drawing a line from 3 to 4, this is another way of doing the triangulation. Polygon triangulation. This is one triangle whose score is 3 into 7 into 4. Multiply all of the weights of each point which is preparing that triangle. 3 into 7 plus 4 plus, for this triangle, 3 into 4 into 7 into 5. 3 into 4 into 5. Definitely I'm seeing that okay, this is a bit smaller. So whatever is the minimum score, we'll just pick that and that will be my answer. Return the minimum possible score you can achieve with some triangulation of the polygon. So polygon triangulation we have to do, and when we are doing the triangulation we are having score of that, and that score should be minimized. So just return the minimized score. We don't have to do the triangulation actually, but we just need to know the number of minimum possible score to get the triangulation. Okay, so this was having only 4 sides. Let's say we have a polygon something like this: 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5. Let's say these are my points. 5 points I'm getting in form of array: 1, 2, 3, 4, 5, and every point is going to have some weight. In this case, this is not a weight. Weight will be something like this: W1, W2, W3, W4, W5. And these are in the right clockwise direction. And what we have to do is we have to break this polygon into triangles. So how do we do it? Let's say if I draw a line something like this from 5 to 2, then this is the triangle, but this is not a triangle. This is again a polygon. I might need to draw this line. Now this is a valid triangulation of this polygon, but there might be other possibilities. Let's say if I draw it with a blue color, this and this. So 1, 2, 3. These 3 triangles are there. There's already a typical question, which is ways of triangulation. Number of ways of triangulation of a given polygon. That is a question which is based on Catalan number from dynamic programming series. That is just for your reference. It's like a miscellaneous note, so you can ignore it. Okay, so what we got it that there are n number of ways we can triangulate this polygon. And what are actually the ways? Let's try to figure it out. So if I'm having 5 nodes, 1, 2, 3, 4, 5, and if I have to do the triangulation, then if I keep 1, 2 as a node, 1, 2 as a base when I'm trying to create the first triangle, then using 1, 2 as a base, I can have 3 as a third point, 4 as a third point, 5 as a third point. So I have 3 possibilities. So using 1, 2 as a base, I can make 3 triangles. So from a polygon of size 5, I can create triangles which are 5 minus 2. So from polygon of n size, I can do the triangulation and I'm going to get n minus 2 triangles. Okay, but in this case, I can either take 1 and 5 as a base. If I take 1 and 5 as a base, I have 3 ways. How do we have 3 ways? Let me show you. 1, 2, 3, 4, 5. Let's say this 1 and 5 is the base. Using 1, 5, I can have this as my first possibility of the triangle. If this is the first possibility, then do the triangulation of this polygon as well. And that can have 2 ways, either this or this. So this is one triangle. And the second triangle that I can have is this one, with 1, 5 as a base. And what is the third triangle? Third triangle, let me take it for green. And this is the third triangle. So with the base of 1 and 5, I can choose one more extra point. And when I'm choosing one more extra point, I am left with some other polygons. So let's say I was having 5 points, 1, 2, 3, 4, 5. And those 5 points are 1, 2, 3, 4, 5. Let's say this is the polygon. In this polygon, what I have to find out is I need to create some kind of function. That solution, this polygon I'm giving it to you, and you just return me the score of triangulation, minimum score of triangulation, that is an integer value. So this is something we have to decide what we are going to take. We are going to take this whole polygon. And how do we take this whole polygon? Let's see. Okay. So here in this case, if I try to just solve the problem, maybe let's say I'm taking 1, 2 as a base and I'm trying to create a triangle. If I'm taking 1, 2 as a base, I'm having 3 other options as a third point. Or in other terms, what I can do is I can take this value and this value as a base. If I'm taking this as a base, I'm having n minus 2 other points which I can take as a third point of this triangle. What is that? It means that this triangle can be there and this triangle can be there, and this is the third possibility. So when I'm taking any one of these 3 points, then I'm left with other polygons. If let's say I have taken 3, then this is one triangle. This is definitely be a triangle. If I'm choosing the first point and the last point and any of the point between these 3, then that is a triangle. And if I take that triangle, what is the remaining section? Remaining section is a polygon, and this section is also a polygon. In this case, this polygon is having a size of 3 with 3 nodes. It means it is automatically becoming a triangle. But let's say if my polygon is of so many sides and I'm keeping something like this, 1, 2, 3, 4, 5, 6. In this case, if I take the first element and the last element as the base, then how many other options do I have? I can have this as a third point, this as a third point, this as a third point, this as a third point. If this 5 is a third point, then what is the score of this triangle? 5 into 6 into 1. And what is this? This is again a polygon. And how do I get the score out of this remaining sub problem? This is like finding the triangulation score which is minimum for this polygon with these sides 2, 3, 4, 5 and 1. 1, 2, 3, 4, 5, 1. Okay, so I am getting an idea. In this case I was having an array something like this: 1, 2, 3, 4, 5, 6. From this point to this point I wanted to get the score, triangulation score which is minimum. And what I did is I'm taking this point, and I can take any of the point between these two. Let's say that is a k point, and this is I and this is j. So I'm taking I, j and k. I is 1. In this case I am choosing k as 5. If k is 5, then on the left side there are no nodes. But to make it simple, let me just make it simple. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is the base that I have chosen. One point is final, second point is final. Let's say this is I and this is j. I can choose k between these points 2, 3, 4, 5. Let's say this is k. If this is k, I, j and k are forming a triangle, and on the right side it is a one polygon, on the left side it is also a polygon. On the right side the polygon is from I to k. I to k is a polygon, and on the left side there is a polygon from k to j. This is also a polygon. So whatever is the score of this polygon, plus the score of this triangle, and this triangle has a score of value at I, value at j and value at k. I already know the score, already given as a part of problem statement. Multiply every single vertex. So this is all I'm doing to get the recurrence relation, problem and subproblem relation. And here I'm getting an idea that starting from this index to this index, if I want to do the triangulation of this polygon, I can do it in this way, that I can choose any k which is going from I plus 1 to j minus 1, and I k can be anything. Then get the score of this, and you will get the answer. So I got the idea of what my problem. What is my problem? My problem is that from the given array, let's say starting index is this, ending index is this, starting point and ending point I'm considering as a base, and middle element I can choose as a third point, and that those 3 points are going to form a triangle, and one polygon on the left side, one polygon on the right side. So from I to j, what is the minimum score to get the polygon triangulation? For that, what I can do is do the polygon triangulation from I to k points, plus do the triangulation from k to j points, plus current triangle which is j, I, j and k. So value at I into value at k into value at j, I, j, k, whatever order you write. So this is the value, and we just have to return it. So this is this is my solution. That's all. Solution of ij is equal to solution of k and solution of k minus j, this. And what is the value of k? Ij is given to me. What is k? K is starting from I plus 1 and going till j minus 1. This is the value of k. And what will be the base case? Base case is something, let's say when my triangle, let's say in this case the left triangle is having 3 nodes. If let's say the left triangle is having 3 nodes, it can get us some score. But if the triangle left portion is having less than 3 points, it means from point I to point j we have number of points less than 3, then definitely the score is 0, because we cannot form a triangle with less than 3 points. And how many points are there from I to j? J minus I plus 1. If it is less than 3, return 0. This will serve as a base case for us, right? And every single point, what I'm doing is I'm breaking down the problem into 2 subproblems, and those 2 subproblems are this: from I to k and from k to j, and this is for all of these cases. Now we are ready with the recursion, and let's start this recursion and see how we can optimize it further. So here I'm going to write a function which is going to give me the answer. Score, minimum score of polygon triangulation. Polygon from these values, these nodes, and starting from first node till the last node. And what is this n? This n is values dot length, and I'm keeping this n as a global variable. Also I'm moving this integer array values to global variable so that I don't need to pass it to every single function call. This dot values is equal to values, and now this is something I have to implement. It's going to be a private function. Will return integer solution integer I integer j. Starting from point I to point j, if I do the triangulation but with the minimum score, base case, and what is my recurrence relation from I to j. If I, let's say, just consider these two elements as a base, then base of the triangle, it means two nodes are fixed for a triangle. What can be the third node? Third node can be from any node between I and j. This is for the third node, starting from I plus 1 and going till j minus 1 k plus plus. And what is the triangulation score? If I choose this k, solution of I to k. This is one sub problem. Triangulation score of all the nodes from I to k, triangulation score of all the nodes from k to j, plus current triangle with the nodes I, j and k. That will be equal to values at I into values at j into values at k. So this is my current answer, and I need to keep track of the minimum possible value of current. So let's say this answer is equal to integer dot max value, and this answer is I'm returning. If this current is less than the answer need to be updated. What is going to be my base case? My base case is when the number of points are less than 3, then I cannot make a triangle. It means the score is 0. J minus I plus 1 is less than 3 because 3 points is the minimum requirement to form a triangle. 3 points is the only requirement to form a triangle actually. In that case, return 0. That's all we have to do. And if I just run it over sample test cases, let's see if I am not missing out any compilation error. Okay, all sample test cases are passed perfectly. Now here we are making too many subcalls. For every single possible value of I and j, we are making 2 subcalls against every single element. Let's say I'm making n, loop is going n times, and I'm making 2 calls, so 2s power n for one possibility of I and j. It is too many calls we are making, but ultimately how many calls we are going to have which are going to be unique? This is I is an index value will always be from 0 to n minus 1, and j is also an index 0 to n minus 1. So in total we have n square unique calls. If unique calls are n square, what is the sense of having or writing exponential solution? So just memorize every single call and just return the stored answer. So for that I will just save the state of this call, input, and this is output, save it. Where can I save it? I value will go from 0 to n minus 1, 0 to n minus 1. I can take a 2D array, one metric side for I, one metric side for j. This you guys must already be aware of. Doing the memorization. Memorization is always an easy part. We only need to take care of recursion. If we are good at recursion, we will also be good at memorization. Integer 2D array, let's say that is dp. dp is equal to new integer of n cross n size and here we will just store our answer. dp of I and j. I have stored my answer. When we are coming inside our solution function, we are doing some processing. This is our processing. After processing, we are doing the caching. Before processing, we have to check in cache whether it is available in cache or not. If this is not equal to null, it means it is already available in cache. Just use it from cache. And now if I submit it, I should be able to pass, because we are making n square time. Now it beats 199% of Java submissions. And yes, this is the code. This is the proper dynamic programming style, where we are getting started with identifying the problem, and then we are deriving the recurrence relation to understand the problem and subproblem. Later on we realize that okay, there are overlapping subproblems, so just memorize them using this dp array. That's all about it. In case you have any doubt, do let me know. There is also a problem which you can do based on number of ways of triangulation of a polygon, that is based on Catalan number. You can practice that question after this. And thanks for watching. If in case you want to have any discussion further, you do join the Discord community. Okay, thank you guys. Bye bye.